Hello there. After assembling your CNC machine, the most important step that many people skip is checking for squareness or squaring the gantry. If your machine isn't perfectly square, every cut you make will be distorted, and your parts won't fit together correctly. In this video, I will show you how to quickly and easily square your CNC machine. There are various ways to check for squareness, such as using laser tools or precision dial indicators. However, I've chosen this simple test cut method because it's the most accessible, and anyone can do it at home with just a digital caliper. Simply cut a square, for example, 100 by 100 millimeters, and measure its sides. One important tip: I used laminate flooring scraps for this test because they are relatively flat, but be careful, laminate is extremely abrasive. It contains aluminum oxide and resins that will dull standard carbide and mills quite quickly. Unless you have expensive diamond-coated bits, it is much better to use a standard MDF board or a piece of flat hardwood if you have some on hand. The first thing I did was draw a 100 by 100 millimeter square in my CAD software and prepared it for the first cut on the machine. I cut to a depth of 2 millimeters, which is sufficient to get a solid, straight edge that is easy to measure accurately with a digital caliper. After the cut, I measured the length and width to ensure that the piece was exactly 100 millimeters. This is crucial because it confirms that my software parameters, such as tool diameter compensation, are set correctly. Although the side lengths were correct, which means the machine is precise in its axis movement, we encountered an issue with squareness. By measuring the diagonals or the sides, I noticed that the square was not perfect. When measuring the square, I got 140.9 millimeters on one side, while the other side measured 142.2 millimeters. I found a squareness discrepancy in my measurement of 1.3 millimeters across the diagonals that needed to be corrected. We will make the correction by taking half of the measured difference. This is crucial because if we were to move the machine by the full amount, we would simply shift the error to the opposite side. Based on our calculations, we have determined that we need to shift the left side of the machine by exactly 0.65 millimeters. This is the precise adjustment needed to ensure perfect squareness. To achieve this, we must manually correct the drive position on that side. Before powering down the machine, I performed a homing cycle to return it to the starting position and engage the limit switches. I am doing this specifically because I don't have to separate limit switches on the y-axis, which means automatic software-based leveling is not possible. After the machine completed the homing cycle, I turned it off and proceeded with the alignment. I used a manual caliper, which felt more reliable, and measured the distance from the ball nut to the lead screw mount, where I had a gap of 14.55 millimeters. I subtracted 0.65 millimeters from that 14.55 millimeters, set the caliper to 13.9 millimeters, and tightened the locking screw to fix the setting. Then, I rotated the lead screw shaft until the gap matched that measurement exactly. Once the adjustment was complete, I powered the machine back on, set up a new piece of laminate, and ran the test again. I am now looking forward to seeing the results and confirming the accuracy of the alignment. The test results were highly satisfactory. Since the measurements are now well within the required tolerances, I can confirm that the leveling and alignment process has been successfully completed. With this adjustment, we have effectively eliminated the discrepancies and ensured the precision needed for high-quality production. How did your adjustment go? Feel free to leave a question in the comments if you get stuck. Subscribe and follow the channel. We have a lot of work and new projects ahead of us.